Hello, everyone. I want to welcome all of you to this session, which is the fourth of 8 sessions that you will be encountering in this program where you are being trained to solve Olympiad problems. There are 2 groups, the junior group and the senior group, and you are in the senior group. Today, we will be dealing with sequences, and in these sequences there are several formulae, and you are aware of some of the sequences already in your school syllabus, and we're going to start now straight away just to go over the important sequences called arithmetic sequences. So let's go straight there without any further ado. So what is an arithmetic sequence? As you can see, an arithmetic sequence is a sequence in which the difference between 2 consecutive terms, okay, terms are like, for instance, 1, 2, 3, 4, that's a sequence where you have several numbers, one after the other, and these are called the terms. So you have a first term and a second term and so on. So the difference between 2 consecutive terms is the same throughout the sequence. Okay, we'll explain that later on when you do the problems. And the first term, we can give it a name, and usually the name that is given to the first term is A, as you can see here. And n is a very important concept. It represents the number of terms. So if you speak about 1, 2, 3, 4, 5, then n is 5, and A is 1. See, that's the first term. Now, why is 1, 2, 3, 5, 1, 2, 3, 4, 5 an arithmetic sequence? Because the difference between any 2 is equal to 1 in that sequence. And therefore, it's an arithmetic sequence. And the difference, since it is 1, we give a name to it. That difference is given the name D. And it's called the common difference because it is the same difference occurs right throughout the sequence. And we often use the symbol L for the last term of the sequence. All right. So you got A is the first term, N is the number of terms, D is the difference, and L is the last term. Okay, so bearing that in mind, we can actually write the sequence. We can say the first term is A, so we can write it down, first term. The second term will be D more than A because the difference between these 2 is going to be A. So you have to add D, the common difference, to get to the second term. And again, it's the same difference that you add to get to the third term. So you keep adding the same quantity. The D may be negative, by the way, in which case the sequence will actually be decreasing because you'll be subtracting something each time. So, and as you can see, the last term is L. And if the number of terms is N, this is the nth term, right? Because there are n terms altogether, 1, 2, 3, and the last one is the nth term, and we use the symbol L for the last term. Okay, and you'll see here that the last term is actually, there's a formula for it. The second term is A plus D, A plus 1D. Third term is A plus 2D. So therefore, the nth term is A plus n minus 1 times D. And the nth term is the last term, and that's equal to that. Now, so this is a very important formula. L equals A plus n minus 1D. Right? Don't go and look at the back of your book for this formula all the time. Remember, the last term is equal to the first term plus a common difference multiplied by n minus 1, where n is the number of terms. Now, from here, you can actually solve for n, and you get this here. It's very easy to see because if you take A to the other side, L minus A, equals n minus 1 times d. So L minus 1 over d is n minus 1. Therefore, n is equal to 1 plus L minus A over d. Now, this is a very important formula. Why? Because it tells you that if you know the first term, the last term, and the common difference, those three things, first term, last term, and the common difference, you can find how many terms there are. All you have to do is to subtract those two terms, right, and divide it by the common difference and increase that by 1. So that tells you the number of terms in a sequence, which is a very important object that problem solvers need to know. How many terms are there in the sequence? All right, suppose we ask the question, if you got a list of consecutive numbers, right? Consecutive numbers are like 5, 6, 7, 8, right? One after the other. If you know the first term, let's call it A, and you know the last term, call it B, how many numbers are there in that sequence? See? For example, if you have the first term is 76 and the last term is, say, suppose the first term is 76, they're consecutive, 76, 77, 78, and so on, going up to some other number, say 1003 or something. How many terms, how many numbers are there here? All right? And there's a very simple formula for this. All you have to do is to say the number of terms, the number of numbers is equal to 1 plus b, where b is the last term. So you increase this by 1, the last term, and you subtract the first term. So please remember that. That's a very important fact. That if you've got consecutive numbers, and if you know the first term and the last term, to find out how many terms there are, normally people might say it's equal to 1003 minus 76. That's not quite right. You have to work out 1003 minus 76, but you have to increase that by 1. All right? I'm not going to go into it, but it's a very simple thing to think about if you follow, if you apply the last result to this. Okay, the first thing that I want to say is, how do you add the number of terms? If you've got several terms in an arithmetic sequence where the common difference is d, the first term is a, and the number of terms is n, and you are adding up all the, if you want to find out what is the sum of all the numbers, right? A plus d up to L, we'll say up to L, then there's a formula for this. It says that it's equal to, usually it's written as n over 2 into a plus L, but I like to write it as n times a plus L over 2. We've got a very good reason for writing it like this rather than n over 2 into a plus L, and that is your sum, S for sum, right? Okay, now this formula is very, very interesting because you can rewrite this formula as follows. Divide on both sides by n, and you get S over n equals a plus L over 2. Right, now why is this important? This quantity is a very important concept in arithmetic, because S is the sum of all the numbers, and n is the number of numbers. So therefore, when you add a number of numbers in a collection, and you divide by the number of numbers you have, you're working out the average. So this is the average of all the numbers, while this other quantity is the average of the first and the last, because you're dividing by 2. So that's very interesting. The average of all the numbers in an arithmetic sequence is the same as the average of the first term and the last term. Very useful to know. See, it's the average of the first and the last term. And the average of the first and the last term is, if you got an odd number of terms, the average of the first and the last term is always the middle number in that sequence. Like for instance, if I had the sequence, say 3, 7, 11, 15, 19, I keep adding 4, right? If you find the average of the first and the last term, 3 plus 27, is 30, and the average of those two is 15. 30 divided by 2. There you see it. That's the middle term. You got 3 on this side, you got 3 on this side, and I've got an odd number of terms. So the average of the first and the last term is always the middle term. Okay, so it tells you something nice. So therefore, the sum, you can work out the sum if you know the middle term and the number of terms, because then this is the middle term, m, middle. So n is equal to the middle term multiplied by how many numbers you've got. That gives you the entire sum. So this is the theory that you need to work out the problems that we are about to do. The first problem that we are going to tackle is problem 92 of my book, which is called 1000 Olympiad Problems. This is the book that you have been using thus far. So we're going to problem 92. You can see it on the screen. I wrote down the integers 25, 26, 27, and so on, all the way up to 208. Okay, so you got all these numbers. How many digits did I write down? So each one is a digit. I wrote 2 digits here, another 2, and so on. How many digits are there altogether? So that's a problem that we are going to now tackle. Okay, let me just go to my whiteboard. So we have the numbers 25, 26, 27, all the way up to 208. So if you want to calculate the number of digits, you'll see that there are 2 digits in the beginning, all the way up to the last 2-digit number is 99. And then thereafter, you have 3 digits. Next one is 100, going all the way 101, and it goes all the way up to 208. So here you've got 2 digits each. So if you want to count the number of digits, you have to find out how many numbers there are here and then multiply that by 2. But earlier on, we saw that the number of numbers here is 1 plus 99. We know it's an arithmetic consecutive numbers, right? And you increase the last one by 1 and subtract 25, right? And that gives you the number of numbers there altogether. Okay, that gives you 75. And then if you want to know the number of digits, that's equal to 2 times 75, because each of these 75 were 150. Okay, so the number of digits less than 100 is 150. And likewise, if you want to work out the number of digits here, you increase 208 by 1 and subtract 100, and that gives you 109. 209 minus, then you multiply that by 3 to get the number of digits there. So you get this 327. So the total number of digits that we wrote was, we wrote 150 up to 99. And after that, we did another 327. And that gives you 477 digits altogether. Okay. We move on to problem number 156, which is indicated in this on the screen here. So We're looking at this problem here. Given that you've got a fraction with where the top is a sum of several numbers, at the bottom you also got several numbers, and that when you simplify this, you get 2013 over 2014. So the question is, what is the value of n? Okay, now to do this, we need to know something quite important, and I'm going to tell you what it is. Now, by now you would know that when you add the first n natural numbers, 1, 2, 3, 4, up to whatever number you want, n, okay? We said earlier on that this is equal to the number of numbers, n, multiplied by the average of the first and the last. And you got 1 plus n, if you like, put n plus 1 over 2, okay, which is commonly written as n into n plus 1 over 2. Very important formula, which you should not forget, okay? And then the sum of the first natural numbers. In fact, another useful thing to remember is the sum of the first n odd numbers. Suppose you got odd numbers, and there are n of them. Now, remember, we said that the last term in this is a plus n minus 1d. So a is 1, n minus 1 times d. d is 2 in this case, because the common difference is 2. And if you simplify this, you'll see the last one is 2n minus 1. 2n minus 2 plus 1. So this is the sum of the first n odd numbers. And the answer to this is that, again, just as we did before, you got n terms altogether. You find the average of the first and the last. And the average of the first and the last is you add the 2 and divide by 2. And when you simplify this, 1 minus 1 cancels, 2n over 2 is n, you get n squared. So the sum of the first n odd numbers is n squared. It's a very useful fact. 1 plus 3 is 2 squared. 1 plus 3 plus 5 is 9, which is 3 squared. So it's equal to the number of numbers there altogether squared. So the problem in this was 1 plus 2 plus 3 going all the way up to yeah, I think it was I'm sorry, it was 2 plus 4 plus 6 going all the way up to 2n, and you are dividing that by 1 plus 3 plus 5 all the way up to 2n minus 1. And as we saw up there, this thing here at the denominator is just the square. This is the number of numbers here is n. Here too, the number of numbers is n. So if you work out that, the n is the number of numbers, and the average of the first and the last is 2 plus 2n over 2. And when you simplify that, you get the 2's cancel, n into n plus 1 over n squared. And that gives you the n's cancel. And you get n plus 1 over n. Right? And I think it was upside down. I'm sorry. The problem was like that. So this is really 2014 over 2013. I forgot exactly what the fraction was, but I remember something like this. So you can see now, this is one more than that. So n is equal to 2013. Okay. So that takes care of this problem here. which is problem number 156. The next problem we want to tackle is problem number 22, and you can see it here. It reads as the decimal form of 3/7. In other words, if you write the fraction 3/7 as a decimal, then you get this number here, 0,42857, and so on. 428,571, and so on. Right. The question is, what is the digit in the 2004th place? All right, we see that the digit in the first place is 4, and you got 428,571. Those numbers are repeated, 428,571. So essentially you have groups of 6. They keep repeating themselves, groups of 6. And you want to know what is in the 2014th place. So the question can be answered if you know how many groups of 6 there are in 2014. So let's look at analyze that question. And what do we see? Okay, so we've got 0, 428,571. Keep repeating like this. But they're in groups of 6. And you're looking at something in the 2014th place. So you really want to know how many groups of 6 are there going all the way up to 2014. Okay, so it's like looking at the first multiple of 6 or the last multiple of 6 before 2014. Okay, that'll give you. So you're adding several 6s to get to 2000, to a number which is less than 2014. So the way to do that is to see how many 6s are there in 2014. This is a simple problem because you simply have to divide this by 6. And you will see that when you divide by 6, you can do that by hand. You got 335 remainder 4, which means that there are 335 groups. And there's a remainder of 4. In other words, you got 2014, 2013, 2012, 2011. And the last group of 6 finishes there. That's the 335th group, right? If you multiply 335 by 6, you'll get 2010. And then after that, you go up to 4, 14, and 4 other steps. Now remember, the last number in this will be the last number in the group of 6. So the number just before the number which occupies the 2010th position, that's a multiple of 6, right? 2010. It's going to be the last number in this group. So, and that is 1. So if this is 1, now you can see what the rest of it will be. Because after that is going to be 4, 2, 8, 5. That's how these numbers go. So the 2014th one, the answer is 5. Right? Once you know the one just closest to this, then the answer is 5. There's another way of doing this thing. You could have said, for instance, the first number is 4, and when does 4 come again? It occupies the 7th position. 7th number is also 4, and then you have to keep adding 6s. If you keep adding 6s, you're going to get 4. So you want to know which is the last number here, which is 4. Now this part here, 1739, is an arithmetic sequence. And you want to know which term in the sequence is the last term before 2014. So if you argue it that way, then you got an arithmetic sequence here where the A value is 1 and the D value is 6. So the nth term of the sequence is it's A plus n minus 1D, right? So it's A plus D is 6 into n minus 1. That's the nth term. Now all these terms are equal to 4. Just remember that. So this number here is always equal to 4. This term will be equal to 4. You want to know which is the last one, which is before 2014, right? So you're looking at all these numbers here, and you want to see the one which is closest to 2014, and now that becomes an inequality. And when you work that thing out, you get 6n minus 6, you get 2019, right? And when you'll see that n is equal to 336,5. So the value for n is 336 in this case. Okay. So then when you work out n equals 336, you'll see you're going to get or if you want, you can say the remainder when you divide by 6 is actually equal to 3. So the 2011th term, that's the remainder 3, that number there is in the sequence. It's the last number in the sequence before, because you're looking for the largest value of n, which satisfies this inequality, and you will see that it's going to be that. So the 2011th one is 4, right? There it is. You can see the 2011th one is 4. Sorry. And you can track your way to 2014. So you could have solved it in that way as well. The next problem that we want to look at is problem 496. And you can see what it is. It says, for how many positive values of n are both half n, or n over 2, and 2n, two-digit integers? I'll repeat that. For how many positive values of n are half n and 2n, both two-digit integers? The two-digit integers start from 10 and go up to 99. So you want this thing here to be a two-digit integer, and you want that to be a two-digit integer. So in other words, both of them must lie between 10 and 99, because those are the two-digit integers. So let's take it from there and see what we can make out of it. So in this problem, you want half n, n over 2, and 2n, right? You want both of them to be two-digit numbers. So what does that mean? It means that 10, they lie between both of them lie between 10 and 99. And this is an integer. They say n over 2 is an integer. So for n over 2 to be an integer, n must be even. Right? So let's unpack this one here. What does it say? It says that multiply by 2 and you get n is greater or equal to 20. So putting that together with n is even, that means n is equal to 20 or 22 or 24 and so on. So, and what does it go up to? This thing here says that n is less than or equal to, if you divide by 2 on both sides, you'll get n is less than or equal to 49,5, but n is an integer. So you want this number to be less than 49,5, and you want an even number. So the last even number before 49,5 is that you have to stop here because n cannot exceed this number here. Right? The next one would have been 50. So the question is, how many such n are there? Straight away you can see it. And as I told you, that you got a sequence. This is an arithmetic sequence. Common difference is 2. And you know the first and the last term. So the number of terms here, if you remember, I told you, remember a formula? It's 1 plus last term minus first term divided by the common difference, which is 2. And you got a common arithmetic sequence. If you know the first and the last and the common difference, you can work out the number of terms. Now, this is easy to work out because this is 15. So the answer to this problem is that there are 15 such n's. We go on to problem 95, which is right at the bottom of the screen. And here the problem says, calculate the value of 2013 minus 2009 plus 2005 minus 2001, and so on, all the way up to 29 minus 25. Okay, so you're starting from 2013, the signs keep changing, and you stop at 29 minus 25. I'm going to try to remember that, because now when I get to my whiteboard, I'm going to write down 2013 minus 2009 plus 2005 minus 2001. The signs alternate, minus, plus, minus, plus. The next one will be plus, and it goes on like that until you come to 29 minus 25. Now, you can see here that when you take these differences between two consecutive numbers, you're going to get 4 all the time. All right. So you want to know how many such pairs are there in the sum. All right. So to answer that question, because you're grouping them in twos, you'd like to know how many there are altogether here, and then you'll know that half of that will be the number of pairs. So let's see, how many numbers are there altogether here? Okay, this is the same problem that I've been discussing, because you've got an arithmetic sequence here. You've got 2013 minus this and so on, then and you're landing up with this. So the number of terms is 1 plus 1 plus, right, it's equal to the last term, which is minus 25, right, minus the first term, the first term is 2013, divided by d. Now remember, d now is actually equal to 4, minus 4, because you are decreasing these numbers by 4. Okay, so this is what you got here. And if you work this thing out here, you got 2028 divided by 4, that's 507. So it seems to me that you got 508 pairs here. Okay, I'm sorry I made an error there. I'm using that formula uh, as though that this is an arithmetic sequence, and it isn't, unfortunately, because you're subtracting 4 here, you're adding negative 4, in other words, and now you're adding something else here. So the consecutive terms, you're not adding the same quantity. So you can't use that formula, right? So the question still remains, how many groups of 2 do you have here? That's a question I'm asking here, right? So how do you count the number of groups of 2? The trick is actually to just take the first of each of these groups and count those. Okay, and to do that, if you look at the first of this, okay, this gives you the first group. The first one, suppose you count just these numbers, then you are actually counting the number of groups. So you want to know how many numbers are ringed in red there, right? And that becomes the sequence: 2013, 2005, all the way up to 2009. And you want to know how many terms are there in this sequence. But this sequence is arithmetic now, you see, because it's decreasing by 8 all the time. 2013 plus 2005 plus, and then the next one will be 8 lower than that. And there we said the way to do that is to say 1 plus, you take the last term minus the first term and divide it by, but be careful, you have to divide it by -8, because D is -8 in the sequence. It's decreasing, so you're adding -8 to get the next one. Okay, and when you calculate that, you've got 249. So what does 249 represent? It means that there are 249 pairs. And each pair is equal to 4. So therefore, the answer will be 249 times 4, which is 996. Problem 765 is the problem that we are going to look at now. It says here, if the pattern below is continued, determine the middle number in the 25th row. So we must determine the middle number in the 25th row. Here, the rows are given. Row 1 has got just one number, that's 2. Row 2 has got 2 numbers. It goes to the 4 and 6. Those are the next 2 even numbers. Row 3, it continues from 6, you go to 8, 10, 12, 14, 16, 18, 20, and so on. So each time, the third row has got 3 numbers, the fourth row has got 4 numbers, fifth row has got 5 numbers, and so on. So we are looking at the 25th row. So therefore, the 25th row will have 25 numbers, right? And we want to know what the middle number of that row is, right? So what we're going to try to do is to work out the very first number in the 25th row, okay? I'm going to work out the very first number in the 25th row. And to do that, I'm going to first, instead of looking at this triangle here, I'll divide everything by 2, because then I can do the counting. You see, 2. So I'll replace each one of them by that number divided by 2, in other words. So I'll put a 1 here, 2, 3, 4, 5, 6, 7, 8, and so on, right? And that gives you a nice count, because that tells you you're counting 1, 2, 3, 4, 5, 6, and so on. And then finally, if once I get the answer, I will double that answer to get to the actual answer, to the middle number in the 25th row. Okay, so to be more precise, this is, I've set it up here in the whiteboard. So this is the problem that we're looking at, and we want to know what is the middle number in the 25th row. So as I said, we will replace all these numbers by just half of them. And then we see now, we observe here that the last number in each row, this row, is the count of all the numbers in the triangle. So all the numbers in the triangle, 1, 2, 3, right? So that's the last number. 6 is 1, 2, 3, 4, 5, 6. You count all the numbers in that triangle will give you the last number here. So the last number in each row is the count of the total number of numbers in the triangle. And you'll see here that the first row of the triangle is 1, and here you got 2, and you got 3, and so on. So if you look at the last number in the 25th row, it has to be 1 plus 2 plus 3 plus 4. Right? As you can see where my cursor is, 1 plus 2 plus 3 plus 4. Right? All the way up to 24. Right? Up to 24. And that will be the last number in the 24th row. Right? Now we know a formula for that. Right? This is the sum of the first counting numbers, the first natural numbers. And we said it is n into n plus 1 over 2. And n is 24. So 24 times n is 24 times n plus 1, which is 25. Divide that by 2. Cancel the 2's. 2 goes into the 12 times 25 is 300. And this is the last number in the 24th row, is 300. Row 24. Right. So what happens is the new row will start at 321, and it's got 25 numbers here altogether. Because each row n, row 4 has got 4 numbers, row 3 has got 3 numbers. So row 25 will have 25 numbers. So you want the middle one in that 25th row, it has to be the 13th number. That's the number which is right in the middle of 25 numbers. You'll have 12 on this side, 12 on that side, and that makes 24. So the middle one will have to be 13. So all you have to do is to say it starts from 301 and it goes, you count up to 13. So the 1, 2, 3, 4 is counting up to it. So straight away you can see the middle number is 313. And I've got this down here. But that will be the middle number of this triangle. So the middle number in the other triangle, you have to double it, right, to get to that answer. So the actual answer is twice times 313, which is 626.